So now we will move on to question number 154 of set HH. The question reads, which of the following carbocations is expected to be most stable among these four options? So if you have a quick look at it, we have three components with us. We have a NO2 group, we have Y, and we have an H, and there is a carbocation present with us. So it goes without saying that this is basically an intermediate that is involved in an electrophilic aromatic substitution reaction. What drives the product of an electrophilic aromatic substitution reaction is the group that we have with us. Here it is NO2. NO2, as we know, is an electron withdrawing group. It performs -I as well as -R effect. So it is a very strong electron withdrawing group. So it goes without saying that 3 and 4 are out of the question, because here, since carbocation is present on the carbon, which is directly attached to the NO2 group, it is going to be extremely unstable because it anyway is having positive charge, and NO2 is further removing the electron density from it, which thereby increases the energy of these two compounds. Hence, these two compounds are extremely unstable. Hence, these two, we have to rule them out. Now, coming to the right question, we have left with option 1 and option 2. What happens is, whenever you have an electrophilic aromatic substitution reaction, you need to remember that NO2 group is a meta-directing group, because the effect of resonance, like the -R effect, the resonance effect by which NO2 removes the electrons, is highest at ortho and para positions, and it is therefore, for this reason, NO2 group is a meta-directing group. Hence, in this electromatic aromatic substitution reactions, NO2 being meta-directing group, we will be having a substituent Y present at a meta position, and accordingly, we will have a positively charged cation, that is, positive charge will be present on a carbon which is adjacent to it. In this case, the situation was perfectly reversed, because instead of having a substituent at my meta position, I had positive charge at my meta position. Hence, if you realize, the intermediate before this particular product was going to be very unstable, and hence my option 1 in this case is going to be the correct answer. There are two major factors. One is my NO2 is an electron withdrawing group, and thereby my NO2 is basically a meta-directing group. Whatever substituent that I have here, it is substituent Y, is going to get directed to the position of meta, so that I get the most stable product. And hence, option 1 is correct for question number 154.
Explore more about the topics you love with Topper. Subscribe now and keep learning.